So let's start the solutions of today's test paper. So first question is, for the redox reaction taking place in a cell, E naught cell is given, we have to calculate E cell. So reaction is zinc solid, plus copper 2 plus aqueous, it will give Zn2 plus aqueous plus copper solid. So here zinc is getting oxidized, 0 oxidation state to plus 2. So oxidation take place, whereas copper plus 2 is converted into 0. So reduction take place. So zinc loses its 2 electron, 0 to plus 2, and copper accept this 2 electron. So here net electron exchange will be 2. Therefore, according to Nernst equation, E cell will be E naught cell, that is 1.10 minus 0.059 upon net n. How many electron exchange in the reaction? That is 2. Log concentration of product divided by concentration of reactant, and concentration of this solid copper and zinc is taken as 1 because activity we are taking 1. Now concentration of Zn2 plus is 1 molar and copper 2 plus is 0.1 molar. So 1.10 minus 0.059 upon 2 log concentration of Zn2 plus is 1, CO2 plus is 1, 0.1. So it will be log 10. Log 10 will be 1. So 1.10 minus 0.029. So this value will be 1.07 volt. So correct answer of first question is C. Second question is, which has greater lowering in vapor pressure? As we know, vapor pressure depend upon Wendt factor I, but here one is urea, one is glucose, and one is sucrose. All three are non-electrolyte, and for non-electrolyte Wendt factor is 1, and concentration is also same in all three cases. Therefore, vapor pressure vapor pressure will be also same. So correct option is D. Next is question number 53. In question number 53, the vapor pressure of ethanol and pure methanol is given, and ideal solutions form at the same temperature by mixing 46 gram of ethanol and 16 gram of methanol. Then what is the mole fraction of methanol in vapor phase? So first is calculate, we have to calculate moles of ethanol, that is given mass 46 by molecular mass of ethanol 46, that is 1, and moles of methanol, that is given mass 16 divided by molecular mass 32, that is 0.5. So total number of moles will be 1 plus 0.5, that is 1.5. Therefore, according to Raoult's law, total pressure total pressure total pressure will be vapor pressure of pure ethanol into mole fraction of ethanol plus vapor pressure of pure methanol into mole fraction of methanol. Vapor pressure of pure ethanol is 42 into mole fraction of ethanol. Moles of ethanol divided by total moles plus vapor pressure of methanol 88.5 into mole fraction of methanol. Moles of methanol 0.5 divided by total moles 1.5. If you calculate this value, it is come around to be 28 plus 29.5, that is 57.5 mm of Hg, that is total pressure. We have to calculate mole fraction of methanol in vapor phase. So as we know, Raoult's law is equals to Dalton. So according to Raoult's, what is pressure of pure vapor pressure of methanol? That is P naught vapor pressure of pure methanol into mole fraction of methanol according to Dalton's total pressure into mole fraction of methanol. Mole fraction of methanol in vapor phase. So mole fraction of methanol in vapor phase will be P naught of methanol, that is 88.5 into its mole fraction 0.5 divided by 1.5, and total pressure 57.5. So it comes out to be around 0.513. So correct answer is C. Next is question number 54. Question number 54. A current of 2 ampere is passed for 5 hours through through a molten metal salt deposited 22.2 gram of metal. What is oxidation state of metal in the metal salt? So according to Faraday first law, W is equals to current into time into equivalent mass divided by 96500. So weight is given 22.2, current is given 2 ampere, time is given 5 hour, convert in minute. So 5 into 60 in minute, convert and then multiply by 60, it is second. Equivalent mass is mass upon n factor. So that is 177 divided by its n factor nf divided by 96500. So n factor will be into 2 into 5 into 60 177 divided by 96500 into 22.2. So it comes out to be 3. So oxidation state of metal will be 3. So correct option is C. Next is bromination of anisole in presence of ethanoic acid. Give a major product. So anisole is so benzene on benzene one OCH3 group will attach. So oxygen has lone pair. So this lone pair after resonance it will be come at ortho position and para position. So it is ortho para directing. So we have to do bromination. So by doing bromination, one bromine will attach at ortho and one bromine will attach at para. But which one is major? Para is major because if it is attached at para, no steric repulsion between group. If it is attached with ortho, then there is steric repulsion. So para product is major, meta is not major. So option is A. Next question is 56. End product of the following reaction is so cyclohexene react with NBS N-bromosuccinamide. So this reaction going by radical mechanism. So most stable radical is at allylic position. So bromine will attach at allylic position. Then it is X. So further react with magnesium ether. It is formation of Grignard reagent. Now Grignard reagent will act as a nucleophile because here negative charge is there and Mg2 plus. So Grignard reagent acts as a nucleophile. It is further react with CS3 C triple bond N. Here nitrogen is more electronegative, so delta minus, carbon less electronegative, so delta plus. So this nucleophile attack on this electrophilic center and this pi bond will shift to the nitrogen atom and we got C double bond nitrogen, here methyl N minus and counter ion is MgBr. In next step there is hydrolysis. So after hydrolysis oxygen will attach here. So during hydrolysis oxygen will attach. So our final product is A. So okay, sorry, one double bond is missing here. So our final product is A. Next is question number 57. Question number 57. Phenol is react with phenol is phenol is react with CO2 in presence of NaOH. So first is phenol is react with CO2 in presence of NaOH followed by acidification. We got compound X as a major product. X on treatment with this acidic anhydride in presence of catalytic amount of H2SO4 will give which of the following compound. Okay, so first step is this base will abstract the acidic proton. It is converted into phenoxide ion. Now during resonance negative charge come at ortho para position, so it is ortho para directing. If it is ortho para directing, it is ortho para directing, so it is further, so it is react with CO2. So in CO2, oxygen more electronegative, delta minus, carbon less electronegative, delta plus. So this is act as a nucleophile. CO2 is act as a electrophile. So nucleophile attack from ortho position as well as para position. So we got two products. One is if it attack through ortho position. Second, if it attack through para position. Now in this case, ortho product is major due to hydrogen bonding. So ortho one is major, it is minor. So major product X is this one. Next, this major product OHC double bond O OH, it is react with acetic anhydride followed by acidification, means for workup. Now oxygen has lone pair, this oxygen has also lone pair, but this lone pair is resonance stabilized. So nucleophilicity is less. It is more nucleophilic, it is less nucleophilic, and in other side oxygen more electronegativity delta minus, carbon less electronegativity delta plus. So this lone pair will attack on this positive center, it form O minus again came back, and this group will leave as a leaving group. So final product is O C double bond O methyl C double bond O OH. So correct answer will be A. Next is question number 58. In question number 58, given is CS3 C double bond O CS3 CS3 C double bond O H. It is react with NaOH. So first step is formation of enolate ion. So one proton is present here, one proton is present here. So first is formation of enolate ion. So we have two conditions. First we enolate from hydrogen 1, second we form enolate from hydrogen number 2. If we form enolate from hydrogen number 1, then we obtain this one. If enolate obtained from hydrogen number 2, then we got this one. So it is aldol, intermolecular aldol reaction. Now if this negative charge came back again, it will shift to the carbon ion, carbon atom, and now this carbon attack intramolecularly on this electrophilic center because oxygen delta minus, carbon is delta plus. So here 1, 2, 3, 4, 5, 6, 6 member ring is formed. But if negative charge from here, it will shift to the carbon atom, and from this carbon atom to this carbon, if it will attack, then it will be 1, 2, 3, 4. 4 member ring is formed, which is not possible. So that one is prefer, this one is not prefer. So now 6 member ring is formed. So carbon number 1 attack on carbon number 6 that contain C double bond O. So when it attack here, I won't be shift to the oxygen atom. So it form O minus. Now carbon number 1, carbon number 2 double bond O, carbon number 3 2 methyl group, carbon number 4, carbon number 5, and carbon number 6. After that, it will be protonate workup, so it convert into OH. Next further is after heating. After heating, from here water eliminate. So we got, so after elimination we got this product. So correct answer will be B. 6 membering and is final product. Next is question number 59. In question number 59, all values are reduction. In all cases, reduction take place. So these values are reduction potential value SRP. Reduction potential value. We have to compare the order of oxidizing power. So what is oxidizing power? Oxidizing power, or you can say oxidizing agent. Those species which oxidize other, which oxidize others itself reduce. And now check the SRP value. If SRP value is more positive SRP value means more tendency for reduction. So better oxidizing agent. So most positive value here is first one, then second, then third, then fourth. So CO3 plus is better oxidizing agent than Pp4 plus, then Ce4 plus, and then Bi3 plus. So correct option is A. Next question is question number 60. In question number 60, Fe2 plus will gain will gain 2 electron and convert into Fe. Fe3 plus gain 3 electron convert into Fe. Their standard reduction potential value is given. We have to calculate what is reduction potential value when Fe3 plus gain 1 electron convert into Fe2 plus. So our aim is to calculate E naught value when Fe3 plus will gain 1 electron and convert into Fe2 plus. So first two reactions are given. In first reaction, Fe2 plus is left hand side. So reverse the reaction. So Fe convert into Fe2 plus 2 electron oxidation. So sign will change, that is 0.440 volt now. Next Fe3 plus is left hand side. So left hand side Fe3 plus will gain 3 electron and convert into Fe. This value is minus 0.036 volt. Now Fe3 plus no Fe2 plus cancel out Fe2 plus. So it will be Fe3 plus electron 3 minus 2 1. It will give Fe2 plus. We have to calculate E naught of this reaction, but we can't add both value because E naught cell is intensive property, and intensive properties are non-additive. It is non-additive, so we can't directly add. But we know delta Z naught is extensive property, and extensive properties are additive. And we know delta Z naught is equals to minus NF E naught cell. Correct? So that for first reaction it is delta Z1 naught, second reaction delta Z2 naught, third reaction delta Z3 naught. So delta Z3 naught is equals to delta Z1 naught plus delta Z2 naught. So delta Z naught is minus NF E naught cell. So first reaction N value is 2, not first for delta Z3. N value is 1, so minus 1 into F into E naught cell that we have to calculate is equals to delta Z1 N value is 2, so minus 2 into F. E naught value will be 0.440 plus minus N value 3, minus 3 into F into E naught value minus 0.036. So F cancel out, so it will be minus E naught is equals to, multiply this one, 0.88 plus 0.108. So that value is 0.772 volt. So correct answer will be option number D. So option D is correct. Next is question number 61. In question number 61, given is CH3 double bond O methyl. It is react with NH2 CH3 primary amine. So here first water eliminate. After elimination of water, it forms C double bond N methyl. Methyl. Now nitrogen more electronegative, so delta minus. It is less electronegative, delta plus. It is react with LiLH4. So LiLH4 is reducing agent. So here reacting species is means nucleophile is hydride H minus. So this H minus will attack on this carbon center and this bond will shift to the nitrogen. So we obtain CH3 CN methyl and here hydrogen and negative charge. After that it is react with water means work up. So we obtain NHMe. So correct answer is C. Next question number 62. So first is C double bond O, C double bond O, OET. It is react with CH2OH, CH2OH in acidic condition. So So out of this C double bond O and this C double bond O, first one, this one is more electrophilic because here is OAT group. If there is OAT group, so oxygen lone pair will give me its electron density. So it is less electrophilic. This one is more electrophilic. So there is protection of ketone group. The first step is protection of ketone group. Next, it reacts with LiLH4. It is reducing agent that will reduce ester into alcohol. Next step, hydrolysis. Again, hydrolysis. After hydrolysis, it will again deprotect, convert into C double bond O, CH2OH. So correct answer will be B. Next is question number 63. So one is oxygen lone pair, second is nitrogen lone pair, oxygen less more electronegative delta minus, carbon less electronegative delta plus. So there are two nucleophiles, one and second, but second one is, but this one is more nucleophilic because it is nitrogen and it is oxygen. Oxygen electronegativity is more electronegative is less tendency to for going attack. Nitrogen more electronegative, nitrogen less electronegative, so it is more nucleophilic as compared to oxygen. If nitrogen is more nucleophilic, so this lone pair will attack on this carbon. Pi bond will shift to the negative oxygen. It will again come back. Cl will leave. So finally, we obtain nitrogen, C double bond O methyl and CH2OH and dash position ethyl. So correct answer will be B. Next is question number 64. So K2CrO5 is oxidizing agent. It will convert 1 degree alcohol into aldehyde. Further, more acidic condition, it will convert into ketone. 2 degree into ketone, 3 degree no oxidation. So it is 2 degree. It is 2 degree alcohol. So 2 degree alcohol on reaction with K2CrO2O7. This 2 degree alcohol converts into ketone. Next is heating. So after heating, as we know, it is alpha beta keto acid. So CO2 eliminate and we got final product B. Next is question number 65. Question number 65. Which of the following conversion which of the above conversion the correct order of reagent used? So if I check option number one, in option number one, first is Grignard reagent. So Grignard reagent attack on this carbon center from O minus and CS3. Second step is 2, that is KMNO4. So after attacking Grignard reagent, it convert into 3 degree alcohol. Further 3 degree alcohol not oxidized by KMNO4. So first is wrong. So my mean is I want to say if it is C double bond O, it react with Grignard reagent in presence of acidic condition. So first this oxygen will protonate, CH3 minus will attack on this carbon and we got 3 degree alcohol. 3 degree alcohol, second reagent is KMNO4, does not oxidize. So first is wrong. So now check option number 3. First is first is CS3 MgBr in acidic condition. So we obtained 3 degree alcohol, OH methyl. Next is reagent 4. Reagent 4 is H plus water. Okay, H plus just for workup. Next step is second KMNO4 node. So second step is H plus heating. On H plus heating, alcohol will first protonate. When alcohol is protonate, is converted into OH2 positive methyl. Now better leaving group, it will leave. Carbocation is formed. On heating, got Sergev alkene. This Sergev alkene further second reagent is KMNO4 dilute condition. So dilute KMNO4 will give dihydroxylation. So we got around alkene to OH group. Next step is reagent 3, that is CrO3. CrO3 oxidize 2 degree alcohol into ketone, 3 degree alcohol, no oxidation. So OH double bond oxygen. So correct option will be C. We obtain same product. Question number 66. So as we know, if you apply Nernst equation in this question, so E cell is equals to E node cell minus 0.0591 upon N value. How many electron exchange? Zinc is getting reduced. Zinc is getting oxidized with losing of 2 electrons. Copper 2 plus is getting reduced with the gain of 2 electrons. So net exchange is 2. Log Q. Q is concentration of product divided by concentration of reactant. So graph is between E cell and log Q. So log Q is this value, that is Q reaction quotient. So Y is equals to C plus Mx, equation of straight line but negative slope. So if you compare, then we found कि E cell is equals to C, that is intercept. This intercept is OA and that value is 1.10. So E cell is 1.10. Okay. Now for in this question, E cell is given 1.1591. E naught is 1.10 minus 0.0591, 0.951 upon n value 2 into log, that is reaction quotient, that we have to find, so that is concentration of Zn2 plus divided by concentration of Cu plus 2. So this will be around, after calculating, 1.1591 minus 1.10 is equals to minus 0.0591 upon 2 log, that is Q. So Q will be 10 की power minus 2, that is 0.01. So so for this reaction quotient, this is for this reaction quotient plot with E cell. E cell will give E node cell 1.10 and E cell 1.151, and this ratio will be 0.01. So correct answer will be option number B. Next is question number 67. So in question number 67, first is 2 degree alcohol ACC oxidation. So 2 degree alcohol converted into ketone. Second one is 1 degree alcohol ACC oxidizing agent. 1 degree alcohol converted to aldehyde. So one is aldehyde group, one is ketone group, that is best differentiated by Tollens test. Option number C. Next is question number 68. Question number 68. Which of the following compound will give positive test with I2 NaOH, means iodoform test? Which of the following option will give iodoform test? So for iodoform test, suppose there is one ketone group, so it will give iodoform test if at alpha carbon, if minimum 3 hydrogen must be present. So first option is CH3, CH3, CH2, 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 sorry, CH3, then 4 CH2, 1, 2, 3, 4, then C double bond OH. So aldehyde group here is 2 hydrogen, so does not give iodoform test. Second, CH3, then again 3 CH2, 1, 2, 3, then C double bond O CH3. So it contains 3 hydrogen, that will give iodoform test. Similarly here 2 hydrogen left hand side, right hand side, and it is 1 degree alcohol. 1 degree alcohol does not give iodoform test, but if it is 2 degree alcohol, 2 degree alcohol in 2 degree alcohol I2 NaOH, it will oxidize 2 degree alcohol into ketone. In that case it will give iodoform test if at alpha carbon 3 hydrogens are present, otherwise not. So correct answer is B. So question number 69 is the vapor pressure of pure A is 450 mm of Hg, and vapor pressure of pure B is 700 mm of Hg. The total vapor pressure of liquid is 600 mm of Hg. So there is one correction, we have to calculate mole fraction in liquid phase. not vapor phase. So as we know, total vapor pressure is 600 into 450 into mole fraction of XA plus 700 into mole fraction of XB. It is 450 mole fraction of XA plus 700. In place of XB, I can write 1 minus XA. So we got 450 XA plus 700 minus 700 XA. So minus 100 is equals to 700 minus 450, that will be 250 XA. So XA will be, XA will be 100, 100 divided by 250, that is 0. Okay, is minus 250, that is 0.4. Therefore YB will be 1 minus 0.4, that is 0.6. So correct answer is A. Next is question number 70. Question number 70. So given is CS3 C triple bond CH. It is first react with BH2 THF, BH2 THF tetrahydrofuran. So first step is this hydrogen will attach to more hindered side because it is small with more, and more hindered group with less hindered side. So we obtain CH3 CH double bond CH2 double bond CH BH2. So during the mechanism, whatever the carbon at which BH2 will attach at the same carbon after oxidation H2O2, we got at that place OH group. It is hydroboration oxidation. Then further it will getting tautomerize. After tautomerism we got aldehyde. So first one is aldehyde. Second, CH3 C triple bond CH. It react with HgSO4. So during the mechanism, alkene first attack on Hg2 plus. It form cyclic transition state, and here next step is attack of water. So if water attack here, and second case is water attack from the right side. This attack is favorable, this attack is not favorable, because if this bond will break carbocation here form is more stable. So OH will attach here. So CH3 COH double bond CH2. After that it will tautomerize, we got acetone. So correct option will be one is aldehyde and one is aldehyde and one is acetone. So correct option will be B. A will be acetone and B will be aldehyde. Next is question number 71. Question number 71. The vapor pressure of acetone is 185 torr when 1.2 gram non-volatile substance was dissolved in 100 gram of acetone at 20 degrees Celsius. Its vapor pressure was 183. What is molar mass of the substance? So as we know, P naught minus PS, P naught minus PS divided by PS is equals to molality into mass of solvent, by 1000. Here is acetone. So I value is 1. So I am not considering I value. I value is 1. So pure is 185. After adding non-volatile solute, vapor pressure is 183. Divided by 183 is equals to molality. Molality is number of moles of solute, 1 upon 2 divided by given mass upon molecular mass. Weight of solvent. So weight of solvent is 100. Convert in kg. Multiply 1000 into mass of solvent. So mass of acetone is 58 upon 1000. So it will cancel out. So it is 2 by 183 is equals to 1.2 into 58 divided by mass, molar mass into 100. So molar mass will be 1.2 into 58 divided by 100 into 2. It will be 63.6, approx 64 gram. So answer will be 64 gram. Question number 72. The coolant used in car radiator in an aqueous solution of ethylene glycol in order to prevent the solution from freezing at minus 0.3 degrees Celsius. How much ethylene glycol in gram must be added in 5 kg of water? So, as we know, delta TF is equals to I into KF into molality. Delta TF. So, pure water is 0 degrees Celsius, so it is 0.3 is equals to ethylene glycol, non-electrolyte I value 1, Kf value 1.86 molality, given mass, given moles upon weight of solvent. So it is given how much ethylene glycol we have to find, how much ethylene glycol if we add, then freezing point is decreased by minus 0.3 degrees Celsius. Okay, so it will be W upon molecular mass of ethylene glycol 62 in 5 kg. So 5. So W will be 0.3 into 62 into 5 divided by 1.86, that is around 50 gram. So it is 50 gram. This question is question number 73. Question number 73 is 0.01 molar solution of this compound in water had a freezing point depression 0.056 degrees Celsius for water. K value is this one. The number of moles of AgNO3 that is required to react with 1 mole of this complex is. Okay. So this question is based on depression is freezing point. So delta TF is I into KF into molality. Delta TF will be 0.0056 I value into KF 1.86 into molality. Molality is 10 की power minus 3. So I value will be 0.0056 divided by 1.86 into 10 की power minus 3. That is around 55.6 divided by 1.86. That will be 3. So nothing is mentioned. So we consider alpha value is 1. So dissociation is 1. I is equals to 1 plus n minus 1 into alpha. Alpha value 1. So I value is equals to n. Means n value will be 3. So if n value is 3, what is formula of the complex? Means after breaking of this complex, 3 ions will be formed. So expected formula is Pt NH3 whole 5 whole 4 2 Cl2 inside the coordination sphere and 2 chlorine outside the coordination sphere. So after breaking of this complex, we got Pt NH3 whole 4 Cl2 2 minus plus 2Cl minus 2Cl minus. So number of ions will be 3. So if this complex react with AgNO3, then this part is, that is ionization sphere. So coordination sphere, ionization sphere. So ionization sphere, this chlorine will be react. So it is 2 chlorines. So 2 moles of AgCl we obtained. So answer will be 2. Next is Cannizzaro question based on Cannizzaro reaction. Which of the following compound will give Cannizzaro reaction? So condition is, so Cannizzaro reaction is shown by those compound it at which around the C double bond O next atom will have no alpha hydrogen. It should not have no alpha hydrogen. So first is this complex having one hydrogen, so it does not give Cannizzaro reaction. Second, it has two hydrogen, not give Cannizzaro reaction here and here. So it is attached with directly C double bond O. Here no hydrogen, so it will be give Cannizzaro reaction. So it does not have hydrogen, it can also give Cannizzaro reaction. Similarly, at this carbon there is no hydrogen, so it will give Cannizzaro reaction. This also does not this also give Cannizzaro reaction because around C double bond O next carbon has no hydrogen. Similarly, this compound is also give and this compound is also give. So 1, 2, 3, 4, 5, 6. Total is 6. So total answer will be 6. 6 molecule will give Cannizzaro reaction. Next is question number 75. So 1 kg of 0.75 molar aqueous solution of sucrose when cooled up to minus 4 degrees Celsius before freezing, the amount of ice the amount of ice that will be separate out. Okay, so we have 1 kg of aqueous solution of sucrose. So 1 kg means 1000 gram. Let in this 1000 gram, x gram will be water. So 1000 minus x, it will be, this gram will be sucrose, correct? It will be sucrose. So as we know, delta TF, it is equals to I into Kf into molality. Now check molality, calculate molality. We have to check how much solvent is present, how much solvent is present. So molality is number of moles of solute, that is 1000 minus x divided by molecular mass of solute, molecular mass of sucrose 342 into weight of solvent, that is x, we have to calculate. So it is in gram, so multiply by 1000, so it will be in kilogram. That is equals to molality is 0.75. So here it will be around, after calculating, x value will be 795.86 gram. This means, weight of solvent water is 795.86 gram, and rest part is sucrose. And we know कि freezing on freezing only solvent crystallize, no solute crystallize. So now in initially initially we have how much, mass of solute. So water is, weight of solvent is 795.86. So 795.86 is water. So sucrose is, weight of sucrose, that is 204.14 gram. So if this mixture is freeze, then sucrose does not freeze, solute does not freeze, only solvent part will freeze. So that W we have to calculate. So delta TF is 4. So delta TF is I into Kf into molality. Delta TF is 4. What is I value? I value is sucrose, for I value is 1. Kf value will be 1.86 for water into molality. So what is molality? Molality is number of moles of solute. That is 204.14 moles of solute divided by molecular mass 342 into weight of solvent, that we have to calculate, into 1000. So here W will be, this W will be around, so after calculating, this W will be around, it will be around 277.5 gram. So initially mass of water is 795.86, now it is 277.5. So weight of water, that is convert into ice. So ice separated will be 795.86 minus 277.5, that is around 518.3 gram. Thank you very much.